Now, the next test or feature of this new topology is to demonstrate that now we have a self-healing capability that if pod fails for any reason, Kubernetes will create a new pod just to have the same number of pods available. So if I look at the stateful set, which controls how many instances of specific pod I should run, and I see that a desired state for our API manager a stateful set is 2. So if one fails, Kubernetes will try to meet that desired number of pods running. So in order to do that, I'm going to run a force command to kill that one of the pods. And if I look at the pods, yeah, it was killed, and immediately Kubernetes creating a new one, and with all the images already located on those nodes, the startup time is really fast. So that's another great feature. The next one is we can do an upgrade of the existing pods with a different image. So you created a new configuration, you built a new image, and now you want to replace the existing image with a new one, and you can do it in uninterrupted fashion. So right now I maintain 2 pods of API Manager. And if I look at the stateful set for the API Manager using the YAML format, one of the sections says update strategy rolling update. So this is a default strategy, which means that if there is more than one pod is running, then the pods will be updated one at a time. And also just to confirm what level of Docker image I run, I'm going to see that in the stateful set command for Docker register that we have, and we are running version 762-01. That's the image that we're running. So let's update stateful set with a new image, and Kubernetes will take care of replacing that image. So this is a command to patch the stateful set, but before I hit enter to execute that command, I'm going to start a load test against API Manager to demonstrate that during this upgrade, there will not be service interruption from the client point of view. So this is my health check load test. I started, so it will run for 4 minutes. And this is the error column that I'm interested in. I hit enter, it's patched, and now if I look at the pods, I should start seeing, yep, one of them is terminating. So API Manager 1 is terminating. There is some provisioning inside the stateful set to wait a little bit for completely terminating that pod. So there is a grace period for killing that pod and creating a new one. So it will take some time to terminate each pod and then create one. But we also have a check in place to make sure that before that pod will be available to service request, we verify that that pod can actually service those requests. And the way we do it, I'll show you in the stateful set. We have, besides the update policy, we also have a way to do a readiness probe. And basically, we use the same endpoint health check to make sure that only when Kubernetes can access that endpoint successfully, it will update its configuration for the API Manager service that this pod is available for servicing request. So let's see how we are doing with pods. Okay, both pods, or the first one at least, are running, but it's not ready, as you can see. Now it's ready, and the second is terminating. And if you look at the SOAP UI, it still shows no errors. So the same logic applies for the second pod. It will be terminated after a grace period, and then the image will be updated, and the new service will be available. The new pod for the service will be available. Okay, it's still terminating. And then we'll check if the image was really updated, that we have an endpoint that didn't exist in the first version of that image. So we will access that endpoint to see if we have a successful result back. Okay, so the second image is up and running, but again, it's still doing some verification because it shows that it's not yet ready. Okay, now it's ready. And all right, we didn't have any errors, so I will stop this load test. And this is the endpoint stock quote that did exist in the previous version. So I'm going to execute that, and it comes back successfully. So that's good. So we have the new image, and we can also verify that by executing the following command. We get a Docker registry, and now we see that we have a new image with a different tag called test. So now we have the new image created or updated in our cluster. And as you could see that there wasn't any service interruption, at least for the health check endpoint that we used for the load test. This concludes the demonstration. Thanks for watching.